In this video, we will talk about how to find a formula to count the number of permutations in general. So that's our goal. We're trying to find a formula for the number of ways to permute k objects from a set of n objects, where the order in which we pick those objects matters. So remember, our notation for the number of permutations we were saying is p of n comma k. That's the number of ways to permute k objects from a group of n objects. All right, so we want to find the number of permutations of k objects from a set of n objects. Okay, so we can do this following our idea from the last video. So let me scooch this over a little bit. Let me move this over to give myself some more room. Okay, so we can think about how many ways there are to choose the first object in our list. Okay, so we have n total objects to choose from, so there's going to be n ways to pick the first object. And then for the next stage of this experiment, let me put an n here first. For the next stage, I'm going to multiply. So we're going to use the multiplication principle because we have these different stages of this experiment. All right, so now once we've picked that first object, there are n minus 1 objects left to choose from. So there's n minus 1 ways to choose or to pick the second object, because it could be anything except what we picked first. Anything except what we picked first. So we get n minus 1 there. And if we kept going like this, now for the third object, we could pick anything except for the first two objects that we've chosen. So that leaves us with n minus 2 choices for that one. And then we'd keep going like this. Each time we'd subtract 1 from this value until we get to the end. And overall, we're choosing k objects. So there should be k total numbers in this list. So what value goes in this last spot exactly? Okay, so one thing to keep in mind is this the very first number here, the n, I can think of this as n minus 0. So with that in mind, every single number in this list is n minus something. So even this last one should be n minus something. It's just n minus how much exactly. So the way I'm going to think about that is, if I think about this number that I put second, n minus 1, it was n minus 1 because that value could have been, we could have chosen anything except for the first, what we picked first. And that's why it was n minus 1. We had n minus 1 choices left. Similarly, the next spot is n minus 2 because we could have picked anything there except for the first two objects. So for this last spot, we could be picking anything. Ooh, let's write that better. Anything except the previous. Because there's k total objects we're picking. Before that point, we would have picked k minus 1 objects. So k minus 1, that is how much we're going to have to subtract from the n. So n minus k minus 1. So there are going to be n minus k minus 1 ways to pick. This is the kth object in this list. So if I distribute that negative sign and I evaluate this, we end up getting n and then minus k plus 1. So let's write down this formula in general. So the number of permutations, remember we're calling that p of n comma k. And we just got that it equals n times n minus 1 times n minus 2. Dot, dot, dot. Keep going, keep subtracting 1 each time until you get to n minus k plus 1. So this is one of the more important formulas we're going to see in this section. So I'm going to box it. I'm also going to highlight this so it really really sticks out. Okay, so one important thing to keep in mind is, remember, there are k total numbers in this list when we're permuting k objects. So let's do an example. You have 20 books. In how many orders can you put 14 of them on a bookshelf? So if we practice our notation, we are trying to count the number of ways to permute from a set of 20 books to permute 14 of them. So we're trying to find p of 20, 14. All right. So if we think about our formula, we know that this should be like n times n minus 1 times n minus 2. I'll keep subtracting each one until I get to this very last value. Conceptually, the reason for that is, for the first book, I have 20 choices for what goes there, any of the 20 books. And then for the second book that I put on the bookshelf, there's now 19 choices, anything except what I picked first. For the third book that I put on the bookshelf, it could be anything except for what I picked first and second, so there's 18 choices left. And I would keep going like that. So I'm going to put a dot, 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 times whatever number is last. So the formula can help me quickly figure out, well, what number goes last? So if I work out n minus k plus 1 for my specific values, n is 20, minus k is how many objects we're permuting. We're permuting 14 books on this bookshelf. And then plus 1, and that ends up being 7. So that is the number that goes there. And one thing that I could verify is, if I were to actually list out all of these numbers, 20, 19, 18, 17, all the way down to 7, there should be 14 total numbers. And that should make sense because I'm trying to permute 14 of these books. Okay, so we end up with 20 times 19 times 18 times dot, 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 times 8 times 7. So if I wasn't allowed to use a calculator or something and I needed to write down my answer, I could leave it like this with that dot, dot, dot notation. Okay. There is another way I could write this. So I want to make a note of that. And what I want to notice is this product, 20 times 19 all the way down to 7, it's almost like a factorial. This is sort of like 20 factorial, and 20 factorial is 20 times 19 times 18 times dot, 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 times 2 times 1. But it's just a little bit off. So in fact, let's see if we can use that fact to our advantage. So we have 20 times 19 times 18 times dot, 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 times 7. So what I'm going to do is I'm going to multiply this on the top and the bottom, kind of like if I was getting a common denominator. And I'm going to sort of complete the factorial. So to complete the factorial, I would need to multiply by 6 times 5 times 4 times 3 times 2 times 1. But whatever I do on the top, I got to do on the bottom. So 6 times 5 times 4 times 3 times 2 times 1. And if we do this, now the numerator is 20 factorial. And the denominator is 6 factorial. So this is another way I could write my answer. And it's more concise than the way that I had written my answer before. Okay, so in general, we can do this sort of thing. So in general, we can write P of n comma k, if I'm trying to write my formula for the number of permutations, in this factorial form. So that would look like P of n comma k. So the first formula we had for P of n comma k, let me write that better. P of n comma k was n times n minus 1 times n minus 2 dot, 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 until we got to n minus k plus 1. So I'm going to use this same multiplying the top and the bottom by something trick to complete the factorial. So I would need to keep subtracting 1 from all of these terms on the top. So if I look at n minus k plus 1, and I subtract 1 from that, we would get the next term is n minus k. And if I subtract 1 again, I would get n minus k minus 1. And I would keep going like that until I get down to 2, and then finally down to 1. And let's multiply by the same thing on the denominator. So n minus k times n minus k minus 1, dot, 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 until I get to 2, and then 1. Because whatever I do on the top, I have to do it on the bottom. Because when I have the same number on the top and the bottom of a fraction, overall that means the fraction is just 1. And if I'm multiplying something by 1, it's not changing the value of it. That's why multiplying on the top and the bottom by the same thing is an okay thing to do, because it's not changing the value when I multiply by 1. All right, so what does this give us? The top is now a factorial. We have now completed n factorial. The bottom is also a factorial. It's n minus k factorial. Okay, and I'm going to put this in a box because this is, let's put this in a red box. This is another formula for the number of permutations of k objects from a set of n objects. And I'm going to highlight this. So this is the formula that involves factorials. So it's a little bit quicker to write. And this formula is particularly helpful when k and n are large. So for example, in the problem that we just worked out, picking 14 books, placing them on a bookshelf from a group of 20 books. Those are both relatively big numbers. So initially when we worked out the number of permutations, we had to multiply 14 numbers together. And that's long to write, and that's why I put the dot, dot, dot. So using this factorial form can be helpful and more concise when our numbers are large. So the next video, we are going to talk about what 0 factorial is. So in terms of our goals, for this section, over the last 2 videos, we have finished our first goal, which is defining what permutations are and doing some examples where we count them.